I'm gonna dream this one. You're gonna wake up in the middle of the night. This meeting.
Good. It's still on Zoom. So I don't yeah, we're gonna have to have some conversation about this. Just to handle that. Yeah. Sure. Hi, Katherine, if you're online. Saw you there. Yeah. I'll unmute you.
Hi, Damion. I can hear your audio, but it's not exactly a clear signal.
Okay. Saying it's a little rough hearing us.
I mostly am hearing room noise, and I'm not clearly hearing your words.
Let's see. Okay, well, the important thing is that we hear you, so I'll give an intro, and then I'll hand it over to you, Katherine.
Damion, I think your microphone is on.
No, it's not muted. Now it is. That's 1, 2, 3. That's Karen, right? Yeah.
I think it's better,
Well, it's muted here, so. Okay, so I'll introduce Katherine now. So this is the first afternoon session. LLM. Oh, I've got it worked. We are still recording. Okay, good. So this is IFOW 2024 at the University of Twente, and we're into the third seminar or workshop session, and it's called LLM ChatGPT and its role in ontology development, database knowledge graph search. So we know LLMs are having a big impact right now on many projects, and the ontology community is trying to figure out how powerful they are, how much they can help us do our work, and where the division of responsibility is. So with that said, I'd like to introduce Dr. Katherine Thornton, who's somebody I've had the pleasure of working with for a few years. And so she is an information scientist working on Wiki Food Composition Database project. It's been contributing to Wikidata since 2012. Member of the Chefs community group. And she says Wikidata aims to provide web access to food composition databases, which allows researchers and consumers of food composition data to query this in combination with data from Wikidata and other RDF resources. So finally achieving this federated data vision that ontologists have been promoting. And Katherine has to know how to do it also. She's a member also of the Joint Food Ontology Work Group. So track about that too. So over to you, Katherine, and I'll just stop sharing here. Thank you. Let me know if you have permission. Yeah, your slide there. Full screen.
Thanks, Damion.
Yeah.
I have provided a link to these slides here on the first page. Oh, Damion, I'm hearing myself also in the an echo of everything I say.
Okay. Does anybody else have their microphone on?
Oh, you have to move your.
I'm going to mute mine and see if that makes a difference.
No, you have to move the microphone on the main computer.
Here?
On the main computer. Yeah.
Okay. Right on the.
Okay, I'm not hearing anything now, but I saw a thumbs up. So if I don't see other hand signals, I'll proceed. Awesome. Thank you, Damion. I appreciate it. I have provided a link to these slides here on the cover slide if you'd like to have a copy of the slides or follow along. And everything in this color blue here is a link in the slides. So many of the resources that I'll be talking about are linked from the slides. Today, I'll be talking about ChatWikiFCD, nutritional data integrity in complex language model applications. This is collaborative work, and I want to acknowledge the contributions of my co-authors, Dr. Mika Matsuzaki, a nutritional epidemiologist at Johns Hopkins, Kenneth Sealsnut, the software engineer who designed and built this system, and Kenneth is here with us today to participate in the discussion and answer questions as well. And I am Kat Thornton, and I'm the information scientist contributing to this project. Many of you are probably familiar with the many projects of the Wikimedia Foundation. And today specifically, I'm going to talk about Wikidata, and more specifically, I'm going to talk about the data that is in Wikidata related to food composition, related to nutrition, related to chemical compounds, some of which we talk about as nutrients, and data about food, dishes, cuisines, and things that are of interest to the Joint Food Ontology Working Group. And particularly, I'm going to talk about Wikibase. Wikibase is the software that enables Wikidata, and Wikibase is free and open source software, and anyone can use Wikibase to create their own knowledge base of whatever data they're interested in. So inspired by Wikidata, we created our own Wikibase for our project called WikiFCD. And WikiFCD is a knowledge base that specializes in food composition data. And the approach that we have taken is to present data that has already been published, mostly from national level food composition tables, in the form of a knowledge base that's available for anyone to consult on the web. So often these food composition tables are published in print form and then also published sometimes as PDFs or CSVs or other types of files that you can download and look at. When we contribute data from these published sources to our knowledge base, then any individual food composition value across any of the tables can be queried and combined with other data in the knowledge base, allowing us to ask questions across food composition tables and also to remix the data in interesting ways that is more convenient to do from a knowledge base rather than working with the files in their original formats. So I have listed here some of the food composition tables that we have already uploaded into WikiFCD, as well as a link to, excuse me, where you can find the knowledge base on the web and explore it. And these are some examples of what some of the food composition tables that we consulted look like in their print form. So WikiFCD is a public knowledge base of food composition data. And every single statement in WikiFCD is referenced back to the published source from which it was drawn. It's really important to us that we be able to keep all of the statements connected to their original source publications so that if anybody wanted to know where any particular value came from in the knowledge base, they would be able to directly connect it back to the published source. We have many multilingual labels in our knowledge base, and we're always aiming to add more multilingual data if possible. We also have mappings to Foodon, and we also have mappings to Wikidata. So it's possible to combine the food composition data that's in WikiFCD with other data sets of interest from Wikidata. And you can do that through federated SPARQL queries on the WikiFCD SPARQL query endpoint. So if we have this knowledge base of food composition data, why did we create ChatWikiFCD? ChatWikiFCD is primarily what we'll be talking about today. Excuse me. And ChatWikiFCD is a chat interface for the WikiFCD knowledge base. We wanted to create a prototype of a chat-based interface for our knowledge base because we wanted to see if we could use LLMs to enable search in additional languages, and to also see if this chat-based interface might make it more approachable, more inviting, more convenient for additional people to interact with the data that's in WikiFCD. So the WikiFCD interface is available in the generic Wikibase interface. And so it very much looks like a table of data on the web. It is clear in terms of each statement is, it's easy to tell what the property is and what the value is, but it's not the most exciting interface to browse, and it's not intuitive for all users. So we wanted to see if perhaps we could make a chat-based interface that could potentially be more inviting. So some challenges of the WikiFCD interface that we've come across as we've been working with our Wikibase. The search bar that is provided with Wikibase allows you to search the text of item labels and item descriptions. However, not all of the data fields are available in the search. So this means that, let's say you're a researcher interested in selenium. Maybe you would come to WikiFCD and you'd want to use the search bar to search for selenium. And there are many tens of thousands of food items in WikiFCD that do have values for selenium. However, if you use the search bar and your search string was selenium, you would not actually find any of those results. So the search bar only allows you to get at some of the data in WikiFCD. Another challenge is that the data in the statements is really only available per food item in the search, and you really have to know what you're looking for. So let's say you did a search for broccoli. There are many different items for broccoli in the WikiFCD knowledge base drawn from the different food composition tables that we consulted and that we sourced data from. But when you are navigating via the search bar, you're only going to be able to look at one broccoli item at a time, rather than comparing different values across multiple broccoli items. So it is possible to see the data from WikiFCD in a more comprehensive way, but this requires the use of the Sparkle query language. So Sparkle is the query language for RDF graphs, and it allows for flexible, in-depth querying of RDF data, and the Sparkle endpoint that we provide with WikiFCD allows you to ask extremely specific questions of the WikiFCD knowledge base. However, this really limits the pool of people that can interact with WikiFCD to people who are already comfortable writing Sparkle queries. And of course, we'd love to increase access far beyond the pool of people who are already comfortable with the Sparkle query language. And as I mentioned in the previous slide, the look and feel of the WikiFCD Wikibase interface is not inviting to all users. When we were working up the idea for this prototype, we also had a few LLM limitations in mind. So as I'm sure all of you are aware, when asking questions of a large language model, sometimes you get a response back that is plausible, but factually inaccurate. And since food composition data is related to health, it was unacceptable to us to put a system out there that would provide factually inaccurate information about food composition data. And so our one of our motivating questions with this is, can we mitigate the risk of providing factually inaccurate answers, but still make use of all of the great benefits that LLMs can provide? And of course, LLM responses lack explainability. And explainability is something that we really wanted to preserve in this system. And our reason for that is that we spent all the time doing careful data modeling and rigorous QA/QC of our data import into WikiFCD to preserve all of those linkages between individual statements and the original published sources where we found them. And so it was also unacceptable to us to lose those connections in the system that we were hoping to build. So we were really curious to see if we could get around some of the challenges of interacting with WikiFCD by harnessing the power of LLMs and providing a chat-based interface for the WikiFCD data. But we really wanted to see if we could do that in a way where we weren't going to risk providing hallucinated answers to queries that people might pose to the system, and without losing those connections between the statements and where we found them. So our primary question here was, could we guide a chatbot to respond to questions by using data from our knowledge base, WikiFCD? So we wanted to design a system that would only answer questions with factual information drawn from WikiFCD, rather than the system falling back to providing responses based on its own training data. And so we created a prototype system to see if this might be possible. And I'm going to play a demo video so that you can see the system live. And then I will describe what's going on while we watch. So I'm just going to pause it here for a second. And this is the interface for ChatWikiFCD. There are several different example prompts available in the UI. And then here is our question bar, and you can either use one of the pre-generated prompts, or you can ask your own question of WikiFCD. So here, the person asking a question has asked, how much potassium does guava contain? And I'll play the video again. So the person enters the question here, and now we're waiting for the system to generate a response. And the response is, guava contains 150 milligrams of potassium per 100 grams. And you can see that the person interacting with ChatWikiFCD has noticed that guava is highlighted here. And on hover, if you put your cursor over guava, then you'll get this card here to tell you that this is a question about potassium. The value is 150 milligrams. And here is the reference for it. It's stated in the Pacific Data Hub food composition data table. And that is what you see on hover. We also have this sidebar here where you can keep track of all of the entities that are being discussed through the duration of the chat. And similarly, in this card, if you hover over the FCT here, this is going to tell you, going to provide a link for you to the food composition table where this is coming from, and then information about guava taken from that food item from WikiFCD. So if you go to the food composition table link that is provided in that card, you can go to the item in WikiFCD for that food composition table. And similarly, if you follow the link for guava, you can go to the guava item in WikiFCD. So there are links back to WikiFCD throughout the interface for ChatWikiFCD, which facilitates getting to the original data and seeing it in Wikibase, and then also being able to see the references in Wikibase, which you can see here that when the person interacting with the system clicked on guava, this is the actual statement on the item for guava, where we see that for potassium, the amount found is 150 milligrams per a 100 gram sample. And the reference here is that it was stated in the Pacific Data Hub food composition data table. So this ChatWikiFCD not only provides the information in the chat interface, it also provides these links back to WikiFCD itself, where people can look at the data in the context of the entire item, the entire food item, in this case, guava. Another example here is give me 8 facts about strawberries, each in another language. So here we are asking this question of WikiFCD, and we can see here that WikiFCD returns facts in Spanish, French, German, Italian, Portuguese, Russian, Japanese, and Chinese. And each of the facts is a different statement taken from the same food composition table and the same item, strawberry, from that food composition table. And so this really shows how we're getting the benefit of the multilingual affordances of the large language model in being able to translate in all of these human languages that WikiFCD doesn't know anything about. But we're keeping the data from WikiFCD and only WikiFCD. And we're also able to preserve the link for where we have these particular values coming from a published food composition table. And here's the link back into WikiFCD for the strawberry item. And you can see that each of these values, there are multiple ways to navigate back to them from the ChatWikiFCD interface. So now the user is asking, what else can you tell me about strawberries? And here we have additional information about strawberries, but all of the facts about food composition are still drawn from WikiFCD. So none of this is factually inaccurate, and you can navigate back to the data and all of the references for the published sources. In this example, this is a question asking to compare between two different food composition tables, the Uganda food composition table and the Malawi food composition table. And so here you can see that these two values for brown rice are drawn from two different food composition tables, and they do have slightly different values in the two food composition tables. But here, ChatWikiFCD is allowing us to compare them in a single query. And then, of course, you can also translate this question back into English. And this is something that increases the multilingual access to the data in WikiFCD through the power of the large language model. Okay. So the data sources for the ChatWikiFCD application are WikiFCD itself, Wikidata, the Wikipedias, the different language versions of Wikipedia, and Wikimedia Commons. And so images of the food items and images of the flags for the different countries from which we have food composition tables, those images are drawn from Wikimedia Commons. To make the ChatWikiFCD interface more visually appealing, and also to give people interacting with the system a quick visual cue of these different values from different food composition tables are coming from these different places. The flag is a handy way to indicate the source food composition table. And the technologies that we used, the rendering engine is React, the web framework is Vite, the API client integration is Axios, the design system is Material UI. And then in terms of the LLM resources that we used OpenAI GPT-4. We also used LLM Lingua and LangChain to help us process the prompts. So what did we find from this experiment creating a prototype of a chat interface for the WikiFCD knowledge base? We found that we were able to successfully limit responses in terms of the food composition data is entirely from WikiFCD, and nothing is supplied by the training data from the language models. We were able to create links back to the WikiFCD knowledge base in order to provide that explainability that if you get a response from ChatWikiFCD, we want you to be able to go from that response back to the source of where that fact came from. We found that the LLMs provided excellent multilingual conversational support. This really exceeded our expectations here in many of the different languages that we tried, where we do have food composition tables related to a country where those languages are spoken. Now we're able to provide access to this data in many additional languages without even having information about that language anywhere in our system. And ChatWikiFCD provides an interactive interface that we hope will be more approachable and more inviting for people to ask questions of the system without having to rely on a relatively limited search bar in WikiFCD, or feeling like they needed to learn Sparkle or get somebody else to write a Sparkle query for them in order to get the specific data that they were hoping for out of WikiFCD. So I'll say thank you very much, and we're happy to take your questions.
This microphone will pick up anything, but probably not in the back of the room. We'll see. We'll ask Katherine if she can hear way back. Questions from the field about this? Okay, over center row, fourth row, yeah.
So how does the system handle information that's not in the knowledge graph? So how does it behave to ask for the nutrition in the boat?
Did you catch that, Katherine?
I did not. Would you be willing to repeat it for me?
How does this system handle information that's not in your knowledge graph of wiki composition databases?
Great question, thank you. So for if a person asks a question and there isn't information in our WikiFCD knowledge base, then it will not answer that question. So that is a limitation of the system, but it's one that we put there intentionally because we wanted to restrict it only to data that is in the knowledge base. And so there are many questions that this system cannot yet answer, but that's always a great incentive for us to continue adding additional food composition tables to WikiFCD.
Can I just chain one off of that? Which is, what if you asked it for carrot and broccoli nutrients? Is it going to do two separate searches? Is it that smart? Or is it just going to look for some dish that has carrots and broccoli in it?
It does handle multiple entity responses, and I'll let Kenneth answer this question in more detail.
Hi, I hope everyone can hear me okay. But yes, the system is designed to handle multi-entity subject extraction. So that is somewhat demoed in the example where the two examples of rice from different food composition tables was a similar example of that, where it's two separate entities in our data model and they're extracted separately. And then the knowledge graph combines the data and presents that to the LLM through a series of prompts for it to do that comparison. And so similarly, you could ask about two separate food items similarly.
Another question from the floor? Yep.
So I would like to know, how did you deal with the data noise? Because you use an open source, right? How do you deal with that?
So question, I got part of that. How do you use the open source LLMs?
No, he used the Wikidata, which is an open source, right?
Yes.
Database. And how do you deal with data noise? Because open source allows data noise.
Right, okay, so data noise. So question, I think is partly, is your WikiFCD data curated separately from the Wikidata itself, which is known to be noisy? Katherine or Kenneth? Sorry, somehow caught myself on mute. The question was, how do you deal with Wikidata noise? And I think a side question there is your WikiFCD database, those databases are curated separately from Wikidata itself. So perhaps you're not running into a noise issue per se.
Yeah, so the WikiFCD platform is using data that is separate from Wikidata. So that does help eliminate general knowledge from getting into the pipeline and creating noise. There are links between WikiFCD back to every Wikidata item that's relevant. So that helps with getting things like descriptions, other ways to describe food items that allow us to enrich how we search for them. But any nutritional info would only be coming from the food composition tables that we've curated and structured into our own knowledge graph.
Other questions? Yes. Saunders.
When you say the sources, I was wondering what happens when there are sources that are taking output. So one source is, for example, so a 0.6 to that, one says 0.8.
Two different sources having different nutritional profiles, or?
Yes. Yeah, exactly. There's local databases for
Right. So I guess maybe that's connected to, can your system average out nutritional content? Can somebody say, give me the average for nutritional content properly across such and such countries? Is it capable of doing that kind of question? In which case, I think that addresses what we're talking about.
I'm sorry, could you repeat it's like question. Repeat it one more time?
Yeah, so does your system, obviously it's answering questions on a per WikiFCD database data source, but can it also actually average out, do a bit of math on say, broccoli through X, Y, and Z countries?
Yes, so we put multiple sources into the knowledge graph, the WikiFCD knowledge graph, and search is able to span all sources we contribute to the knowledge graph, and that data can then be combined for the presentation layer here.
And if the question was, can we present an average across the different readings for the different food items, the system does not provide an average. That is an interesting challenge, but or an interesting idea that we could look at in the future. But for this prototype, we were looking to only provide exact information as it was found in the source publications. So right now, if you ask it to do that, it will not average across them.
There's a connection, and a question coming from online. Ayana Gupta. Did you attempt any approach before building a knowledge graph, such as a simple RAG approach, for example? I think the question there is to build a knowledge graph, is that the data source that your LLM is working off of, or is it somehow working off of some tabular database or raw format?
I'll answer this and then I'll pass it to Kenneth. We already had the knowledge base. We've been working on this knowledge base for multiple years. So it wasn't that we were hoping to create a chat-based interface and we built a knowledge base to support that. It was that we already had this knowledge base and then we wanted to explore, would this chat-based interface make it more inviting for more people to interact with the system? But I will also
Yeah, I would give the exact same answer. I would also add that because the explosion of the LLMs kind of came right at the time as we were building a lot of our foundational technologies, we also saw this as an opportunity to experiment with other techniques that have emerged, such as RAG, for implementing the chat layers. We made almost a hybrid approach between RAG and knowledge graph extraction, where we kind of have multiple tiers. If the knowledge graph extraction fails, then we fall back to a search-based approach that does follow a RAG loop. And then the rest of the flow is able to handle the data in the same structure. So we keep the schemas the same between them both.
For some of you, RAG means recursive, augmented,
Retrieval augmented.
what was the G part?
Retrieval.
Retrieval, okay. And I guess I'd like, oh, here's a question from Beth.
Yeah, I have one question. How do you enforce exactly that the LLM is not, for instance, giving a source and then thinking of different numbers that are not actually the source? Are you creating SQL queries with the LLM, just parsing it to the system, or how does that work exactly?
Right, something I was wondering too. Your LLM prompt strategy, how do you know that it's not messing with the numbers? Is it that you're using it to construct SQL queries and then getting back the SQL data results?
Yeah, absolutely. So we have a couple of approaches here to improve accuracy. We even put a disclaimer at the bottom saying there might be some instances where it does hallucinate that we haven't caught yet, but we try to be proactive on catching those in testing. But some of those approaches that we tried, that we saw a significant decline in hallucination was making sure that every statement that the LLM creates, we do another prompt that then fact checks that statement against the knowledge graph again. So then that we separate the steps between generating the response and fact checking building those annotations. And so if there's any invalidations between those two steps, then we generate a separate response that says to the customer or the user that there was an issue or an error about it. But for the most part, we also don't trust the responses intentionally, which is why we added those highlighted portions that will give you the 100% factual information from the knowledge graph itself. So if you hover over it and see a number that's incorrect, you'd be able to see the actual verified source next to it. We haven't seen that happen ever since adding these safeguards, but those are extra precautions that we take since this is sensitive data.
So follow up.
Yeah, very short question. Is the verification step then asking the LLM back, or is it just some, for instance, looking for the exact numbers in the source? So is the verification step still based on the LLM?
Is the which based on LLM?
Yeah, so the safeguard step, is it just asking the LLM back, is this present in the source, or is that done in another way? I don't know if I'm speaking loud. Oh, yes. Yeah, so my question was, whether the safeguard step still involves the LLM, so asking back the LLM to refer to the source and for instance, ask whether it's present in there, or is it the double rule-based things, for instance? Or is that too much control?
Kat, were you able to hear the question? I'm having a hard time.
I'm struggling to hear the question also.
Yeah, okay. Yeah, but that's a very interesting presentation. So thank you. I hope you can get that.
I want to get the question and I'd like to go back. I mean, I'm fascinated by how we were able to just whip off these multilingual answers. And so I guess one question, I suppose, is this, I know it's an ongoing project, so one day should you actually go test, send these off to native speakers to have them judge whether the language is used appropriately. Is that true? You're going to have a validation step around that? Or?
Was the question, did we check the translations in other languages with humans?
Yes.
We did not test this with humans at this point. I'll let Kenneth describe how we did test them. This was basically out of scope for this investigation, but it would be fascinating to pursue that in the future in other research.
Yeah, this was definitely one of the ideas we had at the time and resources to find people with very specific language backgrounds to play around with the application and give feedback. We relied heavily on multiple other applications that do translation to compare the responses. So we would take the inputs and outputs and put them into things like Google Translate or other translating tools to make sure that they are on target with a similar response translation back into language that we understand, as a way to approximate that it's speaking accurately. I did fact check it with a couple non-English speakers that speak Italian, but none that speak very specific languages outside of automated tooling.
Just a side note, I know another project that they did in their prompting is wherever identifiers were mentioned or numbers, they would replace them with a phrase of text, such that when we got the answer back and asked for that same text, and then that's how they could sort of create a templated system around this. So, I presume that's how you sort of keep your numbers intact as you're going through to get other translations for the same content. Okay, I'll follow up with that later. So over to Loretta.
Yeah, just a quick question, because the idea is quite interesting. I was just wondering whether both the nutritional and food data in the language were primarily Western, or whether you were also covering Asian or African and so on. The two language and the food sometimes goes in the same related. So are you only primarily Western, or are you covering the various parts of the language? And
I'm sorry, Damion, I was not able to hear that. Could you please repeat it for us?
So the Wiki food composition databases are not just Western diet or Western country, but also Africa or Asia or other places. Is that right?
Yes.
So it is a nation by nation data provided, federated database of resources. Yeah. Okay, anything else when Andrea?
No, I don't know if you want to get time, maybe you can translate. Can you hear?
Yeah. Yes.
Let's start. No, because my worry was also about the language, and one thing that strikes me is that a lot of translation for food terms, a lot of food terms are the ones that we actually can't translate between one language and another. And I'm always really worried when I see machines translating the same term in lots of different languages. So I think there is a lot of loss of semantic content, right, and other forms of content. And so one thing I was wondering, besides the testing with users, is also whether you thought of developing any form of indication of where the translation could use some information. So, for example, marking some color or something that could be a loss of information. For example, I was checking the part of the project online. You have words like rice, rice in English and rice in some other languages. There is a lot of loss of content because in some languages, rice actually corresponds to multiple words depending on whether it's boiled, steamed, white, one form or another. And so, of course, there are multiple uses of the term. If you take a term like pancake or pizza, there are lots of terms that actually have very specific contextual uses. So I was wondering if there is any way in which some of this complexity could be captured with some indicators, with something that could be colors that could flag that within if you're using a translation, there is a potentiality of something being missing that you should double check. I don't know what kind of strategies are being used, but I was just curious.
If I understood your question, you were asking, are we aware of the large potential for mistranslation or loss of some information when translating between languages? And I think I heard you ask about, do we know of any techniques that could automatically flag some areas where there are potential risk in mistranslation that could help increase the performance of the translations?
Yes, and general, what kind of strategies?
So what I'll say, and then I'll pass it to Kenneth, is that certainly the translations are an area that would need additional focused research in future work. For this prototype, we were excited that we could at least support people asking questions in additional languages and hopefully getting something back in a language that they're comfortable with, so that WikiFCD is accessible to people in additional languages. But we are aware that, of course, the risks of translating between languages, we're relying on the LLM performance here, and so it's not going to be perfect. Kenneth?
Yeah, and I would just add that, yeah, as models become more capable, we do see this as an improvement going forward. But yeah, a portion for our project, not to claim that our model is an expert at translation, but that is also another use case for why we do want to make sure that every claim that the response has includes the annotation of where the source data gets. So even if it translates a sentence, maybe that's not grammatically correct, it'll at least maybe show you the source data and allow you to easily get to the real results. But then, yeah, there are some other techniques we could try on top of that. I like the idea of having a confidence of knowing how close of a translation that it was able to generate. We could similarly proxy that with other APIs that do translation as a service and compare results in a natural language processing way. But yeah, that would also be outside of the current constraints of the project.
Stay up. So I'll just add one last little piece to that, which is I can imagine ontologies actually providing a little bit of test information, being of some use still, which is for all the synonyms that we have for food terms, you can actually launch queries where you put in the synonym and see if you get the same result back to your system. And if you don't, then we know synonymy issues and translation issues are avoided.
Yeah, absolutely.
Okay, thank you very much, Kevin and Kat, for this wonderful presentation. Okay, so I will stop sharing. Everyone stop sharing. And we will proceed to the next presentation by Lipika Dey, and I'll have you introduce her while I set up the slides.
Yeah, so Lipika, yeah. So Lipika is a professor of computer science, and a chief scientist at data consultancy services. Research, where she was heavily researching the theme of economic and financial intelligence, and research focused in the areas of artificial intelligence, natural language processing, and data analytics, with a keen interest in healthcare and sustainability analytics. She's a fellow with the Indian National Academy of Engineering and is actively involved in mentorship programs for PhD scholars and activities to promote women in STEM. Outside profession, traveling, looking at professional. Thank you for being here. And yeah, we can get
up to the slides.
Here's the mic.
Yeah. Okay, right. Gotcha. Okay, there we go.
Thank you. Yeah, so as he mentioned, I have been in natural language processing for ages. Food is very new to me, other than, of course, food as a common interest. This is a work which goes on at Ashoka University and University of Arden. Professor Enrich is our collaborator. And in fact, it's his group which has started working mostly on food for personal health information, where food is one of the key components, where key interests of people for keeping track of personalized health, mostly from calorie and other nutritional component point of view. However, when this project started in India, what we realized is none of these things that we were talking about, like food composition table, or even very exhaustive list of ingredients, cooking methods for Indian food, exists in a form which can be used by computers for answering a lot of information. So a very simple thing, all of us know about samosa. It's there in food also as one of the entries. But if we just look at some of the recipes of samosa, that's what we are seeing here. What you will see is they vary in terms of ingredient, they vary in terms of cooking styles, they vary in terms of shapes. Then we come back to the philosophical question of what is really a samosa. So that is one of the things, because what we realize is most of the nutrition or health apps that even a lot of Indians use, they all are built on top of recipe knowledge bases, which predominantly come from the West, because the knowledge over there is a lot structurized, whereas a lot of Indian food knowledge doesn't exist in a very in a form which is very well structured. That's what stops them from using popularly with the health apps. So that was our motivation for building an Indian food ontology. The key problems that we faced is what I will be talking about. No comprehensive Indian food chart with exhaustive list of ingredients and the nutrition values. That's not there still. But before that, an exhaustive list of ingredients and cooking styles are important. So let me just talk about a little about the Indian cooking style, where it's very different from many other cooking methods, because there are a lot of ingredients, a lot of spices which all get together and completely transform the food, where looking at only the ingredients and their nutrition components is not enough to finally conclude what is really the nutrition component of the dish. And that happens a lot in Indian food. And that's where we felt that we need a lot of new relations, properties, etc. in order to express it properly. But in order to even know what all we need, we first needed to have that exhaustive list of elements, both in terms of ingredients as well as methods and everything. And that's where the current work started, where it's a lot of curating information from existing recipe websites, digital content, as well as recipes from authentic Indian book sources, which are not digitized in that way. But we want to get it from there for the simple reason, as I was saying, there's something called an authentic samosa. But there are so many variations of samosa today that one needs to understand what's a samosa and what are its variations. To answer some more questions like, is there really a healthy samosa? But that's something that I'll come to later. So the key point for this work is to curate recipes from recipe blogs, books. No separate digital content is to be created. So that means whatever is written in different languages, different styles by different users, all of that has to be curated and the structured knowledge base has to be built. That is really the aim. So that's why it becomes more of a linguistic language processing exercise to begin with, before we can go for building the apps on top of it, which would be for nutrition assessment and so on. So what are the challenges? Other than, of course, there's no existing list of elements. There are lots of variations in the names of ingredients themselves across India. India is a large country with 26 official languages and many other local languages also. There are regional varieties of the same recipe. There are a lot of socio-cultural aspects of those recipes which put on restrictions on of different forms on a particular food item. And when we come to actual measurements, Indians are very bad in expressing these measurements. There are inconsistencies and there are uncertainties. So that's what are the key challenges that we have to look at when we move from having a recipe to building a knowledge graph of all the content, which will be then parsable and usable to answer Sparkle queries or other kinds of queries on top of that. So this is grossly what we see. We have recipe blogs, we have the text, links, tabular content, whatever is there in a blog. Different blogs have different structures. Some have recipe cards to tell what are the ingredients, what are the measures. Some do not have recipe as usual because people write in different way. It's not a very standardized set of sequential activity. So getting information from there is one of the activities. We look at how we can use LLMs for handling these activities so that we can build a knowledge graph with minimal manual intervention. And as we have a graph, then we can have all kinds of links, and so then we can answer different kinds of questions. So I just take a look at some of the challenges in Indian food. So first of all, the same element may be in different forms. We were saying some forms in the morning, like frozen form or fresh form and so on. We have a lot of ingredients which can be fresh also or dry also, like leaves. We have, for oriented leaves, we have oriented which is dry, and leaves which are dry. There can be fermented variations and so on. Forms can be in terms of shape, like seeds or powder or paste or cuts and so on. So different forms. Again, they are important because they are important for the end product itself, and they are important for the quantity that is absorbed. The name variations I have already talked about it. So here are some examples of what we find in recipe blogs themselves. So when we encounter a name in an Indian recipe, it may be in its English name form, say cumin, but it can be in Roman forms, the Indian name, which is Jira, most often Jira. There can be an even name in a South Indian language, which I also don't know. And there can be the same name, Jira, J-W-E-R-A, in actually some other form. In this case, it's the Hindi Dey family form. And all of them are mixed together in a recipe. That is the challenge that we have to address. People are not consistent when they write a recipe. Then there are quantitative variations which matter to us at the end, like just 1 cup. Now there's no standardization of an Indian cup or an Indian bowl. People say small katori, or katori is a bowl, or a small bowl, a small spoon, and so on. Unlike in the West, where we have a teaspoon or a tablespoon, people are quite inconsistent in this. There are form variations that I mentioned, that it could be seeds or powder or paste and so on, and there can be state variations. So, what we tried to do was, we tried to do all these mappings in different forms and then create a structure in which we can incorporate them. So, handling uncertainties in terms of quantitative measurements is one. We move to the next one, where we find there is even ingredient wise, there can be variations, like we would say, use oil to fry. Which oil they don't mention. Different oils have different properties, and also different oils may have an association to regions. So what we want to do is, if we have here, say, a recipe from 2 different parts of the country. It's there in the name, if you can read at the top. So one is a Gujarati, which comes from the western part of India, and the other is the eastern part of India, a Bengali recipe. Then, when we are curating the knowledge, we try to add additional knowledge from other sources, which are like, if it's western part of the country, then they use mostly peanut oil, whereas when it is eastern part of the country, they use mostly mustard oil. So that's a common knowledge which we try to substitute when we are curating the knowledge and putting back into the knowledge base. So with all of these activities, let me just now take you through a set of steps that we have taken for the curation. We have a selected set of blogs. We haven't worked on all possible sets that we have yet. So here is how a blog looks to begin with. We gather through crawling of the blogs. We get a dump of this file, and then we pass it on to the LLM. We have used GPT 3.5 version. Whereas mostly people use it for answering questions, we are using it for analytical purposes to clear the recipe and get the constituents. So we use with a specific, very restricted kind of prompt to say that stick to the context, generate answers in a particular format, like this, where you pick up an ingredient name, then tell me how much of it was used over here, and so the answer that comes up is pretty much structured rather than utilizing the fluency of LLMs, we use it to generate the answers from the text in a very restricted format so that it becomes easy for me at the next step to further parse these quantities where I can get the entities, I can get the quantity that is used. And additionally, I use the knowledge from the backend, as I was saying, wherever we have these uncertainties over here. And all of it then goes together to build the structured knowledge graph that you now see, which is in OWL format that we have seen. So that is the process where we are using the LLM to get the information from totally unstructured content to a structured format in this. That's our way of using it. The best part is it works very well for multilingual and code-mixed content. So that is where, as you can see, this is one example of a recipe where we have Hindi, we have English, and it's able to extract out the things in a way. Further where, because I have restricted the answering format, so what it is helping me is getting all these information now together from multiple sources also. So I have ginger from many sources. I have adrak, which is the Indian Hindi name for ginger, from many sources. I have adrak in Hindi script and English script. But because I have all of them together now, in various combinations coming from a multiple sources, I now use clustering on top of these strings to get further named entity resolution that wherever there is ginger, it can match to both adrak and ginger. There's a Hindi form of onions, it gets mapped to onions and so on. So LLMs are basically giving me the entities in various forms from various sources in the form of overlapping strings, and I use clustering on top of it in order to get a list of entities which are resolved. So this is how overall the ontology looks. At the moment, we have the core recipe is one of the core entities that we have. Each recipe is an entity in the knowledge graph, and the recipes have ingredients. I showed you some of the ingredients, the usual suspects like onions and ginger and garlic and so on. Milk, various milk-based units, etc. Now, we also have the concept of meals. In India, meal is a combination of various smaller units of different recipes of items. So all that information has to be stored in the knowledge base. So that's how our ontology is designed. Some of the attributes, a lot of them, we are trying to map them onto the food-on already cooking techniques that are there, the Indian names for it. We are in the process of mapping the elements of Indian cooking to the method. So some of them may be just that we have an Indian name, like kuno is for frying. We may be able to, kuno is more like sauteing, so we may be able to do it. If not, we may have to extend the ontology, extend the terminologies themselves. We have a large number of rules and restrictions for the different kinds of food that we have. So we saw some like ovo-vegetarian, vegetarian, these are known. We also have a lot of additional cuisine names, cuisines which have different kind of restrictions. Like a Jain vegetarian is a vegetarian, it doesn't use any kind of meat product. Additionally, it doesn't use garlic, onion, that's one category. It also doesn't use any tuber like potato or yam or whatever. So those are additional restrictions that we have added in terms of the ingredient. The ingredient has a type which is well defined. So we pick up from that this potato is a tuber or garlic onion is a category. milk products, there are certain communities which don't take milk products and so on. So all those are added as extra restrictions. And what's the use of all of this? Because we have recipes, because we have knowledge base, now we can look at what's a J version of a common dish called dal, which is pulses cooked, where if it's pulses in general is vegetarian, but if it's a J version, then it cannot have onions and dal. So that's the utility of looking at this. So current statistics, we have completed gathering of 10,000 plus recipes from 5 blogs. Initially, it results in a lot of ingredients, which after resolution has come down to about 30,000 right now, where these are still undergoing manual evaluations. We have to decide whether we keep human culture and human taste as separate ingredients or different forms and so on. So certain resolutions we are going on with it. We right now have a Sparkle querying facility to work on top of it. Now coming back to the first question about samosa. So, you know, when we did the samosa calorie counting just on the basis of the raw ingredients, very interestingly, even if you ask everyone what's a healthy samosa, you can say it's a healthy samosa. But we did when we do calorie counting on the basis of only raw ingredients, you find the weight and this one actually has same calories, almost same calories. So that's not what's really the way to calculate. What will happen is, what is the transformation that's happening in a samosa when it is deep fried versus when it is baked, whether the texture is remaining same, what amount of unit of butter has to go in place of oil. All these technicalities will have to come in order to come up with the right answers for what is really the effect of having a samosa. So that's what our intent is in ongoing and future work. Right now, a big team is working on curating it from a lot more sources. Interestingly, other than the nutrition aspects also, we are finding some interesting trends in terms of using ingredients. A lot of these ingredients are becoming global now. So rather than a potato-based samosa, which is very traditional, we have mushroom-based samosa and so on, which are counted as healthy, that we don't know, but definitely in terms of taste or variation, yes, it is there. So these kind of analytics about trends of modern India, what are they eating, we want to get into it. We are also in the process of developing querying in natural language on top of Sparkle, something that we heard earlier. That's it.
Okay, questions. One? Okay.
Well, thank you for a very interesting talk. I'd love to hear more about it. But you use the LLMs to sort of make the language translation. The example you showed for Katherine, I think it was, or Thornton. Could you not also use that for the oil difficulty that you said you put in expert knowledge to find out, which part of the country uses which kind of oil? Could the LLM not find that for you based on all the recipes that you have?
So the recipe doesn't mention the kind of oil.
No, but some recipes would, I would imagine.
Yeah, but we have a lot of variation, as I mentioned, that the same fry can be made in a different oil in one part of the country and in a different oil in another part of the country. So what we are trying to say is, if it is not mentioned, then rather than saying one answer, obtaining it from LLM or whatever, we should be answering it from local knowledge about which oil is predominant in which part of the country.
Yes, but could that knowledge not be extracted from the database that you have, which oils we don't want to
From the recipe set itself?
Yes.
That could be, but unless we have all the information already in place, these are kind of information that already exists, like food composition table, which oil is predominantly eaten where, so the oil table of India already exists. Which kind of oil is consumed more where, actually oils have different smells. So one part of the country doesn't like the smell of an oil which is used in another part of the country. So we don't want to sort of use wrong knowledge. Wherever possible, we try to use it for from an authentic source. That's all.
Correct.
Yeah, thank you so much. This is indeed very interesting work. Two questions. Is that this type of work that you do, is it as a research project for development? And if it is the case, what is the viability of this? Who will be supporting the development of this over time? Is it the government? Is it the industry? That's a very pragmatic decision. But my second question, I said that you are working with Enrich, who does work also everywhere, essentially. To what extent do you see, for instance, in a way what you're doing is very similar to the US work that was just presented here? To what extent would you see kind of a coalition of really working worldwide, building a form for instance, the periodic table that are responding? Those are my questions.
So I'll answer your second question first. It is indeed, a lot of work has happened in US, a lot of work has happened in Europe to get all these things together. It has not happened in India. That is why the project has been started. We are also interacting with Professor Zaki, who has worked in RPI on building the food KG with 1 billion recipes. But they have a structure of recipes, and so we hope we can work together and we can go and sort of, enhance it. So that is one of the things. So my purpose of coming here was to interact with the entire group and see what are the possible collaborations, so that the ultimate, there can be interoperability in terms of structures and everything. So that's the thing. The first part, who will be supporting it? Now, as I said, there are really 2-3 ways in which we can go to. Right now, we are working a lot with nutrition experts of India. Our university itself has started a project where it's mostly with the healthcare group who are going to monitor the actual nutrition of these recipe dishes which are prepared in the student mess with the control group, and then finally look at what is it called? I'm just not getting the term.
I'm thinking brain food, but you probably.
No, it's the gut microbiomes. So how is food related to gut microbiomes in controlled experiment with students at the mess? Because the key point is when we are looking at all of these ingredients, food composition table, they are all in the raw form. But when food is cooked, in India, it's a lot about cooked food. We have very few salads and things like that. Our vegetables are cooked to a point where they cannot be recognized. So now the question is, what is the nutrition of the cooked food? Now that can be analyzed chemically, but that's very expensive to go and analyze it every day. So that's where we intend to use our data science and all of these to see how nutrition can be assessed from recipes, where it's not just the ingredients, but the cooking methods which are transforming the ingredients and can become models for calculating.
Can I ask some questions too? Maybe if there are no other questions. So, I mean, I worked a lot on recipes, so I think this, because before a lot of the discussions we had were actually starting from the ingredients. Instead, here you started from recipes, and I find this, you know, it's very interesting. On the other hand, of course, I can see very well the challenges you had. One of the challenges was mentioned, perhaps even in this conversation. If you look at this especially when you're dealing with recipes, it's different than with ingredients. I think, at least for some of them, not all of them, that they are less stable temporally, right, in different ways. Like one of them is a recipe over usually 5 years, 10 years, 20 at the best. It's changed a lot. You know, like ketchup started like one thing, now it's something completely different. Fish and chips started like one thing. So all of these recipes are bound to change. So I was wondering if already as you're developing these, you're also thinking of adding some temporal limitations with respect to after how many years. Like, so if you're introducing in 24, maybe by 30 or 34, it should be checked. You know, if nobody has checked that, there are very high chances that it is not reliable. And then the other, I was wondering if you consider that also about the seasonality, in the sense that I think some recipes make sense all year round, but some others, they absolutely don't, especially if you have any ingredients that are you know, locally relevant, and so they're sourced only sometimes of the year. So I was wondering if also there you have thought or have in some cases introduced temporal measures.
Absolutely important. We have not yet used the temporal measures, but you know, just by a few queries. So as I was showing you the samosa, you know, the change is very interesting. Whereas samosa, very traditional recipe of samosa is not about baking. It's about using all-purpose flour. Now people are changing to using whole wheat flour. They are changing to substitute the ingredients with something that are more healthy and so on. So that's the kind of changes. Question is a little different. What I can see from the recipes change, whether people are also actually eating it or not, I don't know. Because while a recipe section has a lot of creativity, when it comes to people actually ordering and eating it from different places, so those will need some other kind of you know, mechanism to grab the correct data. I can only get the popularity, etc., of these from the logs. That was interesting, because I was indeed checking that what are people clicking on more. So the creative recipes are what are getting more response, because that may be an idea which people didn't have, which they are using it for. But recipe blogs do not actually give directly the health information about people. So that's a separate, you know, how the health of the country is being affected by these, that will need a very controlled experiment. That's what we can see. But yeah, temporality, how things are changing, etc., are absolutely interesting questions which we would like to see from the knowledge. So, a lot of interesting.
And did you do any testing of like representation of Indian food in other parts of the world? Because one thing that I could see this being used is also like with some other colleagues, actually one of them is from Johns Hopkins, like the people speaking before, they looked at food in cafeterias and debates between students' acceptance of the ways in which the cafeteria was representing the food to the students. So you have, say, Indian students sitting in a cafeteria, precisely in a university, you know, in the US or in Canada, and they say this is not Indian, and so they don't have an accent. And they were looking at how the recipe was, you know, defined and how was. So I don't know if any tool like this would be used also for these kinds of purposes. I don't know if you ever thought about using these also for food outside of India, but so Indian food outside of India.
Yeah, it can be looked at because anyway we are just looking at digital content. So wherever it comes from, it doesn't matter to us. Right now we have not looked at. We were trying to more look at Indian recipes in Indian context, precisely for what you mentioned, that what are the Indian ingredients and what are the variations. So as I was mentioning pulses, we have a lot of variation in what kind of pulses is eaten in which part of the country. So the default pulses are very different in the east, west, north and south. So we are just trying to gather that information first, and then when it moves out of the country, there would definitely be variations again. So yes, and we have started very small. We are looking at more funding opportunities for doing this kind of work. Yeah, hopefully we'll be able to do a lot more.
I'll be the first to buy the FKG.IN cookbook, but not 10,000 recipes. Just, you know.
But I don't know. I don't have the watch, but
oh right, the watch puts us at 3:32.
Okay,
so are there other questions?
One more there.
I was wondering, does your web form also get information about the popularity of recipes? So do you know which recipes are more popular than others?
Yeah, that we have.
It would also be interesting to see how that changes over time.
Yeah, indeed. That because we get all the information, we are not focused on that as yet, because our focus was more to get the ingredient list and the relationships. Yeah, but that information is there.
Well, I have another follow-up question, so maybe that's for another time.
All right, thank you. Let's have a break. Yeah, thanks. And so we'll start at 4. Okay? We'll start again at 4.
Yeah, we'll try to start sharp at 4. That reminds me of another job series.
Yeah.
Yeah, I did it.
And you know, that's the LLM
transform the is about to say, how do you represent that? Is there something is there we have a lot of variation because can we salt brine or can we vinegar?
Yes.
Yeah, some videos discussion.
And it will change, as he was mentioning over time. Yes. So,
Yeah, lots to talk about. We have a monthly food ontology call.
okay.
Too busy, it's spring to really popular.
Well, they did it.
Great.
Yeah, sure, we would love to. Yeah, so, yeah, maybe I'd like to after this. No, I also want to hear others, that's very important. Yeah. So, yeah. I'm here, one person.
Hey, do I need to attach my you don't have to if you are satisfied with this. Yeah, so that's all it takes. Yep, great.
It's an executive. Will you be here?
Yeah.
Okay.
Yeah, right. I think you can announce this slide.
Well, maybe we yes, I would like to invite you
I thought it was
to
not that.
another work session. Probably tomorrow.
Yeah, you'll have.
And I would like to invite you
Yeah.
some other colleagues, because you know, it doesn't manage.
It's always such a fuss. Setting up after these.
Yeah. Very well.
It's always kind of technical problems.
Yeah.
It was also a session that last language was this morning. I was there like 10 minutes.
Not alone.
Yeah.
Seems like there are only 4 variables can fail. One of them was. Yeah, I'll wait for the questions. I'm gunning to see. Reason I had Michaela host is our resident robotics person.
Yeah.
I knew she'd be keen to be interested in that whole area of assumption that we humans have about how food is handled.
Yeah.
The robots actually have to learn too.
Yeah.
So, and she's already familiar with the rules.
Yeah,
that's
right.
So, how shall we just read your rule?
Conversation.
Right, yeah. So I'll save my question. Okay.
The body is into the meaning. Okay, but what is your qualification now? Is it? Okay. 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 But I know very well the work that Shamila and Andrea has done with the microbiome.
Yes.
And yeah, and your idea of combining the local information, that's what you get with your recipe. And the microbiome is also very local because it depends on the soil, it depends on the cooking, and so on. And Shamila has done a lot of work there, and I know she'll be tired. Coming back to see whether we can collaborate or on something. Yeah, that's. I assume you want to get. Yeah, me too. Let me see if we can read your writing. Lipika Dey, okay, very good. So I will send you the information for all my activities here, but I'm sure we find your vision that because I've done a lot of work in the good number of years working. Not I myself from business school, but yeah, I am training nutrition finance, basically science. And we were funding from Gates and Iraq at the time, to study the them. Equity, yeah, changed the name before, but that was one of the first. At the time, TCS, we were having Enrich and digital eye. So that's kind of that whole phase that played up in yeah, you were involved in Enrich? Yeah, yeah. Okay, very good. So let's show you.
So. Yeah.
Something like that.
Yes, I'm with you.
But we have met before.
No, no, I was trying to not to travel too much in the past. I'm only now starting because I think, yeah, you have to get the visibility and everything, right? Yeah.
Yeah.
I'm gonna introduce you based on your.
Yeah. So set the text, right? Yeah.
Yes.
Yeah. Okay. Good.
Yeah, that would be really interesting.
Yeah.
And it's a colleague of yours that's presenting after you?
Yeah.
Yeah. So you have a whole group working on these topics, right?
We have a group.
Yeah.
I'm curious if I'm not part of it, although I am working with food safety as well. But there's two groups. It's Wageningen Research. So there's the Wageningen Food Safety Research Group.
Okay.
That's where my colleague is from. And I'm from food and bio-based research.
Okay.
But I do a lot of projects in collaboration with food safety research. So this is one of them.
Yeah, cool. Very interesting.
Yeah.
Yeah. I don't know. Damion has her slides, right?
Yeah.
So,
yeah.
Is it? But it's not time, all right.
Well, 4 o'clock was officially the start. Let's wait for 1 or 2 to trickle in.
Yeah. I see a lot of laptops still open, so. People are coming. And even online.
Couple of people.
A note taker. That's a funny name.
Oh, it's yeah.
Oh,
yeah. She must be down there. Yeah.
Yeah. I mean, you should have your audience. Yeah, I know. It's good that everyone is saying.
Yeah.
Sometimes you have floating around.
Presentations.
Yes. That helps.
Yeah. All right. Is this critical mass? Do you want to wait? I'll leave it to you.
No, I think that's.
Okay. So you can reach people, then I'll put the slide.
Okay. We have this.
It's recording. It's already recording. The microphone is there. Okay, got it.
Yeah.
Record. Yeah. Okay, good.
Do we have to press it or not?
Yeah. So it's not really. I don't think I should take it off. Yeah. Great. Maybe it's not charged. In which case, our one online user may be out of luck. Testing. Test. Test 1, 2, 3. Test 1, 2, 3. I'm not even sure. It doesn't look like this is working. Charge level is fine, but that circuit's not working. So how that happened, I don't know. We didn't touch it. So we just have a note taker online, but it looks like there's enough sound coming through right now. Speaking here should be okay. Yeah. So go ahead.
Okay. So we're having our last session here, which will be on food safety and especially like modeling rules for food safety. And we'll start with Sander Leube. I hope that's correct. And he was a trainee in the data science and informatics group of Borghini Food and Bio-Based Research Institute for 4 years now, where he focused on data modeling and ontology development. And for the last 2 years, he has been involved in projects about knowledge management and linking data in the food domain. And yeah, well, we are very excited to hear your talk. And Damion, I think you need to help me put up the slides. Thank you.
There you go. Oh, I forgot to share. I'm sorry.
Okay, hello everyone. My name is Sander Leeuwen, and I'm going to tell you something about food safety assets and process ontology that I developed together with my colleague Benjamin Rustu, who unfortunately couldn't be here today. This ontology was developed as part of another project called Food Safety by Design. So the initiative of this project came because the European law requires that food should be safe. There are a number of European regulations that say that food should only contain a certain amount of food safety assets in food to be considered safe. Because that's the case, food manufacturers need a plan to ensure that food does not contain any food safety assets. Therefore, this information is needed on which food safety assets occur in foods, and also knowledge on the effective processes and preservation techniques to control and reduce these food safety assets. As part of the Food Safety by Design project, we developed a tool which also uses the ontology and knowledge graph behind it, where potential food manufacturers can fill in a number of ingredients and processes that they apply, and also the process parameters. And based on that, it will give food safety as a profile. Within this project, different parties have done research on this. So the information from these institutes also needs to, it comes from different sources, and they need to be combined. That's why this ontology was developed. What is a food safety hazard? It's any substance or material that can work its way into any food item and cause any foodborne illness or injury to consumers. These are mainly subdivided in 4 categories. Microbiological hazards, so things like bacteria, parasites. Chemical hazards like mycotoxins, pesticide residues. Plus physical hazards like hair, glass, dirt, or allergenic hazards, which are specific for people with allergies, for example, peanuts and dairy. In this project, we mainly focused on the first 2 categories, so the microbiological hazards and the chemical hazards. What information can the knowledge graph store with this ontology? We aim to that it can store the initial food safety hazard, the food ingredient group, and the food ingredient group. We got information on a couple of broad food categories like cereal products, leafy vegetables. But we also want to store initial food safety hazards for side stream ingredients. And with side stream, I mean an ingredient that was previously a byproduct of another process. So that can be, for example, potato peels or brewer's spent grain, or things like beetroot pulp, those kinds of things. The other thing the knowledge graph should be able to store is knowledge rules, which contain conditions of a process in order to eliminate or control or introduce a food safety hazard. For example, when a heating process is carried out with a certain temperature and a certain duration, so that some hazards will be introduced or eliminated. We have a couple of knowledge rules for a couple of processes, but other processes it was less clear whether it was the rule was could be made explicit. In this case, we use warning messages as an indication for an introduction and elimination of hazards. This is in the case with, for example, peeling. The expert could not find enough results in the literature to confirm this. I'm going to tell you, show you something about the structure of the ontology. So basically, can I go back?
The up
The
arrow.
little arrow.
Yes.
That's still there. So we designed, so this is the structure to save the initial food safety hazards. So there's the class of food ingredients and side stream. I approached this first as a knowledge graph, but this is the ontology. So side stream should be a subclass of ingredient, not type. And its food ingredients relates to food material. So every food ingredient contains food safety hazards, which has a broader hazard type, for example, bacteria, and bacteria is has a broader hazard type of microbiological hazard. So either hazard is microbiological hazard or chemical hazard. When it's microbiological, we made the link with the SBI taxon ontology. When it's chemical hazard, we made the link with the CABI ontology. Now, but the second part is the knowledge rule. So knowledge rule for when is a hazard eliminated, when it's introduced. For this, we designed this process effect class. So this process effect class has a number of properties. First, it has a process quantity. I will come back to that later because it's closely related to the heating process. And has a number of conditions. The idea is that this process effect will only occur if these conditions are fulfilled. And then the lower part will take place, and that is either hazard introduction or elimination, and it applies to a specific hazard. To make this a bit concrete, I will show you an example of the knowledge graph. So this is, for example, an example for a heating process. This heating process has 3 conditions. The first condition is that serial products should be selected. The other condition is, so it applies only in serial products. The second condition is that grilling, it only applies for grilling, and it's only, the effect only occurs when the quantity is, the temperature quantity is higher than 120 degrees. This will result in the hazard introduction, which applies to acrylamide. So basically what this says, for food manufacturer, if you have several products as ingredients and you grill these at a temperature higher than 120 degrees, acrylamide will be introduced. The second knowledge rule, it was a bit more complicated because it depends on this calculation. I will explain this in a bit. So this calculation is used to calculate the elimination of microbiological hazards. For this, it needs a number of parameters. There are 5 in here. It's the TREF, the TREF and the Z value, which are linked to the food safety hazards, and the temperature and the time, which are parameters of the process, of the heating process. When you put these parameters in, log n will be calculated. This log n will be compared to a performance objective, and a performance objective is a kind of number that's also linked to a hazard. When this log n is higher than the performance objective, the hazard is considered to be eliminated. And this is how I designed this for the hazard elimination. So the heating process effect is connected to a number of quantities. For example, the TREF, the DREF, the Z value, but also the temperature and time of the process. So the TREF and DREF Z value are actually process parameters of salmonella, and the temperature and the time are process parameters of the heating process itself. Then the heating process has other conditions. For example, heating should be selected. It also depends on the water activity that the product is produced in. Dependent on that, the values of the TREF, the DREF, and Z value might change. And of course, the process quantity condition needs to be higher than the performance objective for the elimination to occur. And that applies to, for example, as the elimination for the hazard salmonella. We don't only have knowledge rule for heating, but we also have one for high pressure process, which was a bit more simpler. This only depends on that the high pressure process is applied and that it has a quantity higher than 6,000 microbar. I'm not sure it's micro, it's probably millipascal. And this results in also results in the hazard elimination of salmonella. Currently, we have knowledge rules for high pressure process, for heating, for freezing, and for storage. The other processes contain mainly warning rules. And we plan to publish this knowledge graph at the beginning of next year publicly, so that everyone can access it. This was my presentation. Are there any questions?
Thank you for your presentation. I was wondering, how do you handle things like mycotoxins and chemical hazards, which are not really, or which are difficult to remove through processes in food hazards? Or are those not defined as food hazards?
Which are not defined as food safety hazards? So what do you mean? Which are
like mycotoxins and chemicals, which are difficult to remove from food, but might be introduced by some contamination. How would you handle those as food hazards in your ontology or knowledge graph?
And you mean contamination to a specific process, or?
No, more like how do you model them? Would you need to introduce other processes to remove them, or extend or is this knowledge graph not applicable for those kind of food hazards risks?
Yeah, so if we have information about processes to eliminate those hazards, then there should be a new knowledge, a new process effect designed where this information is stored, how you can eliminate these hazards. And vice versa, if we have new information on introduction, then also a new process effect should be new instance of process effect should be general. Yeah.
To that, you showed, all of your examples showed the elimination or the introduction of. So there's that delta there that's happening. But do you have the language just to explain that something is contaminated? And then you go look up in your process library and discover there's no way to remove that contamination from the existing. Is that part of your system, your interface idea?
You mean when there's something initial?
Yeah,
contaminated.
It's contaminated with E. coli.
Yeah.
But it turns out your process system has no library solution for eliminating that. So how does a user come up to your system and describe the contamination, and then you decide, then you go find out whether there's a process to eliminate?
No, the user selects a number of ingredients. These ingredients have an initial acid profile, and then the select process and the parameters, and then the resulting acids and then there's a resulting acid profile which shows which acids are eliminated or not. So in this case, if there's no process that can eliminate E. coli will still show up in the resulting acid profile list.
Andrea?
My question was about the hazards that are defined, so to speak, intrinsically and just defined extrinsically. So certain processes may become hazardous in specific environmental conditions, but then which could involve the fact that there are the air is of a certain quality, or for example, if you have certain kind of versions, you have an animal or a little child or something. And of course, that will change if something is seen as hazardous or not. But I was wondering to what extent you'd like to capture these and whether you think about strategies for doing that, even if the person is clear.
Yeah. Our aim was also to capture these conditions. These are not part of our project, so that's out of scope for the domain experts to look at it. But what factors could introduce this by making this link to conditions, this should be easily implemented. So if there's an environmental factor, the process effect will have another link that has condition to this environmental factor.
So can you say it's an environmental factor?
Yeah, so for example, imagine that salmonella is introduced by a certain environmental factor in which the process takes place. then the process effect will have another condition, which will be this environmental factor. And then only when this is met, the elimination or introduction will take place.
Did you have a question?
Yeah,
Oh, sorry.
my question to I was just wondering the knowledge graph and the process that you are examining. Is it later agnostic? Does it apply to different type of food safety? And in terms of decision support, in which eventually it is to be embedded, is it for prevention, for risk assessment, for monitoring? If you could give a bit more information on that.
I think it's mainly developed for risk assessment. So food manufacturers can see a list of what hazards are still in my product, but it doesn't work the other way around. So they can't say, okay, I have these hazards, how can I eliminate them? So it's just they fill in the ingredients, the processes, and the parameters, and based on that, the tool will give as a profile, but it doesn't work the other way around yet.
I think I have a question to follow up on that. So you describe processes and how they can introduce or eliminate hazards. And Michaela is describing processes for her robots to act on. So could she use your knowledge graph to see if the robot uses the cutting board which has previously been used for fish to cut vegetables and that create a hazard?
Good question. I'm not sure, actually. I'm not sure. I think we would have to look at both our ontologies together to see what how it would apply and how it would link.
Yeah, I was actually I had a question too, because I think you're like formulating this very hard conditions that it contains the hazard, right? What if you have more conditional conditions? So is it always that if those conditions hold, it's always that it will have salmonellas? Probably not, right? So it's like if I'm so, and this is probably something that we would need to. And then, of course, we would kind of need to include all of this knowledge in experiment data, in logged experiments, because you would need to know that once there was fish on this cutting board and now there's an apple. Yeah, but this would be really, from my side, this would be really interesting.
Okay,
That modeling it in scenes, where there's a probability that salmonella is on a surface.
Yeah.
Then your library needs to recognize scenes and apply processes to them to take those probabilities from one place to another.
Yeah. I agree. It's also a very qualitative knowledge graph. Yet it's either it's present or not. It does say anything about the quantities. So it's now assumed that if we say it's present, that the quantity is higher than the European standard allows. But I agree that we certainly
more, refine this more and also take into account probabilities of hazards introduction and elimination. Yeah.
Any other questions?
If not, thank you very much. And I think we come to our last presentation. Same university, sending a lot of people here today. Someone to weak here.
Oh, right.
Or you can introduce yourself, but I can also. I'm fine. No, we haven't.
Yeah.
So it's yeah, similar topic, same university. This is Susanna, and again we are talking about food safety and rules. She is you're at the data science team, so it's a different group than Zander, and you have an artificial intelligence background, and you work on European and national projects. Yeah. On food safety, which is really interesting. So, and now we're gonna hear something about extracting knowledge from data using machine learning. Yeah, and the food safety hazard information. Should I try this? No, probably not. So, just a short disclaimer, in this project, I have not used machine learning. It was more of a general thing that I do a lot of machine learning. So yeah, thank you for your introduction. My name is Sana, and I'm going to talk to you about our work on the project on formalizing food safety hazard information. That's also in collaboration with Sanders Group. The problem that we wanted to address is the problem of naming conventions and standardizations, which can arise in food hazard research. So as you can imagine, sometimes people enter names differently, which can already be a roadblock if you want to research on maize or corn, since those terms are not directly matchable if you don't know that they are the same. So the problem here was the variance between and within databases. And our solution that we wanted to try here was harmonizing data through ontologies, in which we try to apply both the bottom-up and the top-down approach, with the bottom-up being the creation of categories based on entries in the databases that we had to our use, and the top-down being more the conceptual kind, where we thought about how to structure the information we want to use in a logical way that is also useful in multiple cases. As I said, we try to both approaches together. So this is a simplified version of the framework that we created for this purpose, which shows a very top-down approach of how we wanted to structure our data sets. So the first thing I want to focus on is that it's very food item, food hazard centric. So we wanted to have a way that is a simple way of connecting food hazard occurrences and food items together and attach them to multiple sources if possible. So we came up with this very simple way of doing so, in which we have a data source that can be literature, media news, or monitoring data that is attached to a food item, and through that food item, you say something about which hazards it can contain.
And the word can is important here because not all chicken necessarily contains salmonella. And in the same way, we want to convey that a food item can have a food hazard occurrence. So we wanted to have the data be structured in such a way that it can capture the contained batches and not say that all chicken contains salmonella. That's why the middle part is more on the specific food products, and then we, which would be more of a knowledge graph because of that. And then we go back to a more ontology part where we specify categorization that are supposed to connect it back to more conceptual way of talking about chicken, not specific chicken AP from 2008. And this is more of the data-based approach, the bottom-up approach that we tried there. I myself am not a food scientist, so that's why I try to derive the categories from the data for both food hazards and food categories. And the use case that we started with was the RACIF database containing a lot of food hazard notifications from all across Europe that convey information about, for instance, products that were caught by border control, about foods containing some hazardous substance. The data is collected by many authorities across Europe, meaning that there are multiple people filling in fields their own way, leading to variance. And it's also legacy data, meaning that the categories changed over time, which also leads to problems there. And there are many variables stored in the database, but what we want to focus on is the food products, food product category, hazard substance, and food hazard category, since that was really the center part of our project here. And the use case focus on specific products was of maize, chicken, and lentils. I did not find a picture of lentils, but here you have these instead. Yes, so to zoom in even further into the food hazard category extraction, the bottom-up part. And what we did there is first look up the categorization that RACIF uses itself, which was not that difficult of a part since it's a closed list of categories such as pathogenic microorganisms or metals. And this became the RACIF food category highest level of abstraction for the category. And since we wanted to store more information, we also looked into the hazard substance and tried to save it in such a way that substances can actually be connected to each other. So specific cases are not only chicken from 2008, but also you can connect it back to chicken. So for the abstract category, the pathogenic microorganisms, it was simple text matching. And for the hazard substance, we did some text processing to remove terms such as traces of and contaminated with to make it more equal and unionize it as much as possible. Then we tried to match it to categories that we already saved. If none was present, we added it to the RACIF food hazard category section, and the process repeated itself until we ended up with a database in RDF format here. And also, I prepared this presentation to be 5 minutes long, so that's why it's quite short. But here we are at the take-home message already. In short, we created a prototype for food hazard information ontology, which has the goal of connecting sources of food hazard information. In the future, we would, for instance, like to also insert another database, such as data from literature about food hazards found in foods. It combines top-down and bottom-up approaches, and so far we used it on the RACIF food hazard notifications. Yes, thank you for your attention. there any questions?
Another research community, but one thing I was wondering is how can this help with mixed cases? So colleagues have the word, for example, safety, we always have the example of cassava, and this is one that I mentioned. So they sell it in the supermarket, nobody says anything about hazardous. You need to know how to put it, otherwise it's going to be bad. So is there, so usually studies you have, you can be in last, because is there a way in which we could capture that the hazardousness of like a cassava in this?
Yeah, what I would imagine is I would go more to the, because yeah, we're not that far yet, but just to think along. I would say that it would be more in this part, on the downside of the network, where you could connect the categories, like in general, cassava can contain this to have more general information. But I don't know about processes, so I don't know if that answers your question. Yeah, because
the type of process that makes it one way or another is how you.
I'm sorry?
Yeah, it's how you process it. That is not the
Yeah.
itself.
Yeah. So right now we don't have anything in there that could also store information about processes. This is more intended for research purposes on, for instance, what types of hazards connect to what types of foods. So it does not have the information in there about how the foods are being processed. I think that would be interesting to add in the end, but we are not that far yet. Yeah.
I would be interested in, you say you use text matching?
Yes.
Can you say what techniques you use?
Yeah, so I tried there to make the text as uniform as possible. So I did some basic text processing, like turning everything lowercase, for instance, and then I used the Lipika distance to match the closest terms to each other with a pretty high threshold, because I didn't want to match things that are totally unrelated to each other. Yeah, I think it would be nice to do something more sophisticated there.
Yeah. I mean,
and also I looked at it like visually, whether there were some terms that could be scraped, or I also used some rule-based reasoning, like for terms that often occur in front of a substance. So I tried to remove that to make them more equal and only contain the substance there.
Yeah. I think I'm not sure how the data looks, but sometimes here this might be a case where word-to-vec might also be having good results, because if you have terms like the Lipika distance, I think if you have an apple and an apple, it's easy. But if you have an apple and a brethren, then it's really hard to match. But sometimes if you have and then if you have a set of words, it's even more difficult. So maybe that's something to word-to-vec. Yeah, it's cool.
I will find.
Yes, and we can also exchange emails.
Yeah, that would be nice.
Yeah.
Yes. Yeah, there's it.
Yes. Yes.
Yes.
Yeah. So, sometimes I think this is a linear condition I can think of. Then the hazard is in water, let us say. So water is not a food item per se in anywhere, but it may affect the crops, or it may affect so
So I try to actually keep the information structure as simple as possible, and what you suggest would require more information about the process, what is happening with the food. So for now, I'm not sure, but I think for facilitate something like that, we would have to add more information about the products on that site, and then I can imagine doing that. But what we want to focus on is occurrences of contamination and what not where they started. So that's why this information is not in here. It's more like this was found somewhere in this food. So this is the only type of information that is can put in right now. But I think, yeah, more information is always better. But, yeah. Yes.
I recall like EFSA is responsible for all reporting to the EU. What's the relation of your project to the hazards that they track? Are you kind of looking at the same data sets?
So RASIF is a bit different, but we also wanted to use the EFSA data set and try to insert it into the same framework. Also because it's a bit more structured, which would be an easier use case than the one we started with. Yeah, I did skip some information because I wanted to keep it visually easy to look at, but at the food hazard item, for instance, I would there's more information about the sample itself, and yeah, so that kind of information doesn't convey. Yeah, we would still have to experiment a little bit more with that, but I think that should be possible to also add. Yeah, but it's not added yet, so there's still no guarantees. I don't want to oversell it either. Yeah.
Okay, I would have a last, because I'm not familiar with the data set. Can you say like about the size, its numbers?
Yeah, so the data set I was working with contains 70,000 entries from around 20 years. So that would be the size for the data set, but it comes from the public data on the European Commission site with the RASIF window that's scraped by us to into a database that contains all those notifications that are publicly available. Yeah.
Does that mean that every sample or every entity in your node in this graph structure is actually a food hazard, or are there also negative samples?
No, there's just positives. Yes.
Could you use this to say something, or use a ontological structure to say something which products are more hazardous, or is it also biased towards certain products already?
I think it's also biased, at least from the RASIF side, because it's what is encountered, and I can imagine that what people are also checking is biased by prior knowledge. So in that way, it is biased. But still, you can look at, in theory, how what hazards are co-occur more often with what kind of products. And, yeah. Yeah.
Okay, I think.
Yes.
Thank you again. And I think everyone is getting tired anyways. Thank you all. And I will give the last word to you, probably.
Yeah, sure. Yep, thanks very much for coming. It felt like a full day. It felt like we touched on many different subjects that all tied together. And it felt like we generated some partnerships for continued research through the next year. So I'm really happy with this. In terms of announcements, what I will try to do is follow up with some of you about presenting at our monthly IFOW or JFOW call once a month. We have 10, 20, 30 people come together to take presentations from particular people and offer comments on the research and the systems that they're doing. So a number of projects here that all fit that. So thanks very much for coming and making it to the end of today. And let's wrap it until next year.
Thank you.
Thanks for looking more.
Yes.
Online.
Yes.
And for keeping us all like and